Okay, we will start in 2 more minutes. 2 more minutes. Okay, let's start. Let's start. Uh, Okay, again, just a reminder 如果你的老师有讲哪里没有出或者哪里有出，记得给我知道一下。我是想着做一个 full revision 我们还有一个 class 就是 next Tuesday, which is one day before your exam, and I'm planning to add one more for the revision. Okay, so we just covered today. I will cover all of waves. So I don't think we need a revision for the waves because we just recently covered it all. And the revision is for the light. Okay, I will talk about light. I will just briefly walk through of all the things that we learned in light. And also I will give you some exercises, which is the past exam exercises to try out in the class. So I will take, here's I'm going to do. The class will take 2 hours. The first hour will be a walkthrough, and then the second hour will be practices. Practices. So I'll give some exercises. Then we will do in class. Yeah, I'm still thinking of the additional class. I'm planning to do it on Saturday night. If you're okay, let me know. If you're not okay, also you let me know so that I can arrange to find the best time for all of you. So just to make sure that all of you can attend. Later I will ask you guys. I'll create a poll or I'll ask you guys in WhatsApp. If you can make it, you let me know. Okay. Later after the lesson, I will update you guys. Yeah. So basically that's it. And then your final exam is on Wednesday, right? After that, no more, right? So yeah. So we'll fit one more lesson maybe on Thursday night or Sunday night if necessary. If really no time, then I'll fit on Sunday night. Because Monday night you have paper on Tuesday, so that I cannot put it on Monday night. I know that you want to do the revision on Monday night for the Tuesday paper, right? Okay, now diffraction. Okay, so the last part of waves are diffractions and interference. Okay, so diffraction 我先讲到 diffraction 的， so 之前呢我们学refraction and reflection 对吗 ？Okay, now here today we learn about diffraction. Now what is diffraction? Suppose that let's say 我们有一个let's say we have an obstacle here. Okay, it can be anything obstacle something in the way blocking so the wavefront. Okay, so the way we draw wavefront is okay. So let's say you have this wavefront approaching the obstacles. Okay. Now, what happened is that this part of the wave of the middle section will be reflected, right? Will be reflected because this waves travels to the right and it hits the obstacle and some part of it will be refracted. Reflected back. Okay, so 中间这边呢 the middle part they will be reflected back. Now, what happens to the upper and lower part of the waves? Now, for expectation, in our expectation is that it will pass like this. Okay, so the upper region will be like this, and the lower region will be like this. This is our expectation, right? So here the middle will be reflected. So I draw an arrow in the opposite line, and then here it will continue goes like this. This is our expectation, right? Expectation. Now, what really happened is that when you have an obstacle, 它不会这样子只是 pass through. Okay, what happened is that it will be diffracted. So diffracted means the bending, the spreading, not the bending. Okay, to be more accurate, I don't say the bending, I say the spreading. Okay, the spreading of the light wave. So it looks like this. After passing through the obstacle, it will become like this, and like this. Okay, you can see the region nearer to the edges, it will be curved upward. Okay, it will be curved upward. In fact, if I draw the direction of the wave, it is traveling in this direction. It's kind of like spreading. Okay, this one we also call spreading. Not necessarily it has to be like pointing away. This is also called spreading. This is also called spreading. So not necessarily this one. So both cases we also consider it a spreading of waves. Now, so in other words, diffraction is the spreading of the waves. Okay. Now, two ways diffraction can happen. This is one way. The second way is that you have a slit. Okay, we call the slit. Slit 意思说是一个tiny space. All right, tiny space like this one. Now, let's say you have a slit. Okay, so the wavefront approaching here. Wavefront is approaching. What happens? So all the water particles, they will be forced through this tiny hole. Okay, they will be forced through this tiny hole. As a result, they cannot fit in, right? So they have to force themselves to fit in and then comes out. That's why after they comes out, after they passes through this space, it will spread. Okay, you can imagine like you squeeze it and then suddenly it expands again. So it's kind of like it spreads out. Okay, now again, the upper region of the waves will be reflected back. So here it will be reflected back, here it will be reflected back, and only the middle will pass through. Right? So in reality, it is not like this. Again, this is our expectation. Okay, this is our expectation now. In reality, it looks like this. Again, we have the space, and then our wavefronts. Okay, so after the slit, it will become a mix of curved and plane waves. Now, here's this very important thing. Is it curved this way? This is plane waves, right? Plane waves, 直的 parallel the waves. Plane waves created by a wooden stick, right? If you dip the wooden stick, we call it a dipper. Okay, you dip it up and down, then you create plane waves. Okay. Now the plane waves after passing through this hole, 它这个不是 circular 的，你要小心。这个有一些 diagram 它会 confuse 你它会画 circle。等下我会讲到多一点有在什么情况下它是变成 circular waves 所以这个呢，它还是 plane waves OK，if you see if you see this one the middle part is still straight， 中间还是直的。OK，so it's kind of like a mix of plane waves and circular waves, and the end section is curved up, a little bit curved up. Okay, but it's not. We don't call it circular waves. It's still plane waves. But what you see is that the direction again it spreads out, right? It spreads. So it is a spreading. So if you look at these two diagrams, so this is two scenarios where the diffraction can happen. So diffraction is nothing but the spreading of waves when what? When it travels through an obstacle, or 它可以是 obstacle or an opening. That's it. Okay, so if you are asked to explain, okay, what is diffraction, then you just take this in. You just write this inside. Okay, is a 奇怪的 OK 这样子 diffractions are spreading of waves when it travels through an obstacle or an opening. Okay, now one thing you have to be careful in diffraction often questions 会很长的这样子问你 OK 有什么是变了有什么是没有改变的 OK 首先我们讲 wavelength wavelength now wavelength 呢如果wavelength 是我 label is the distance between the wavefront 对吗这种一线一线就是 wavefront 所以 wavelength 是这边Okay, I draw an arrow here. It's the black arrow. The distance between the wavefront here. All these are the wavelength. The wavelength, one thing to remember for diffraction, wavelength 是不会变的。Okay, so wavelength they will never change after the diffraction and before they are the same. So after is still the same distance. So the wavelength same. Okay, this is the first point you have to know. GTH wavelength 是一样。Now the second thing that is the same what is it? The frequency. The frequency of 这个 wave the frequency of this wave is the same 为什么？因为你看这个全部这种 wave 它都是来自同样的 source。OK， 可能我讲 OK 这个是 plane wave 对不对？可能你的 source 是那个wooden stick so you dip the wooden stick then you create the plane wave So 那个 wooden stick 是你的 source. Okay, so how fast you dip it, that is the frequency. How fast you create the waves. You can create it very fast or very slow. So all these waves they come from the same source, which is the wooden stick. Okay, so since they come from the same source, then all the waves they are the same frequency. Okay, so this one you have to remember this one. They will always ask you, especially in the objective. Okay, so the wavelength after diffraction 没有变 the frequency after diffraction 它也是不会变the frequency after diffraction is also the same. Okay. Now, so the wavelength frequency the same. What else? 3. The third one is the speed. Okay. Now in waves your formula to calculate speed is v 等于 f lambda 对吗 ？f lambda v 等于 f lambda。所以如果你的 frequency 是一样，然后你的 lambda wavelength 也是一样，这样你的 speed 也是一样。Okay, so the speed is the same also. Now, if all the same, then what is the difference? What is the difference? The only difference is the amplitude, guys. Okay, remember the only difference is the amplitude. Now, what is amplitude? Amplitude is the energy. Okay, if you look at one wave, the amplitude is the height of the wave. This is I draw the wave. So these taller waves has higher amplitude compared to the blue shorter waves. Okay, the amplitude will decrease in diffraction. Why? Okay, 为什么？我们要知道为什么 amplitude 会 decrease 因为 amplitude 是等于 energy 对吗 ？energy OK， 如果你看最后一个图片左下右下角这个图片after diffraction 是发生什么事？它 spread out 对吗？它 spread out所以 since it spreads out meaning that the energy is shared in the wider area, in the wider region. That's why the energy will decrease, okay, because it's shared among a wider area. If you take one point before the diffraction happens, let's say I mark this point X here. Okay, let's say I compare this point, call it point A, call it point A. Now, compare this point and a single point after the diffraction. You'll find that point B has a lower energy than point A. Okay, in fact, not only this point, every point after the diffraction has a lower energy compared to every point before the diffraction. Okay, simply because the energy is shared among. 就好像你 let's say like you have let's say 你有很多钱 ，OK， 然后你跟你的朋友 share，OK， 你派完你的钱去整班朋友 ，OK， 这样你就剩下 you only have a little money left, right? Because you share all your money with your friends. So it's the same concept. So the energy is shared among a wider area, then the energy is now very little now. Okay, it's very small. So the amplitude will decrease. Remember that. Okay, amplitude decrease, energy decrease. So here, if I draw 2D, how does it look like? It looks like this, the wave. So this is the wave before. Okay, before diffraction, your wave looks like this. Okay, so the amplitude is the same. Now after diffraction, let's say we draw a line showing before and after. Okay, so this is the line. On the left is before diffraction, on the right after diffraction. So it straight away it will decrease the amplitude like this. This, and eventually it will slowly fade off. Okay, I draw the equilibrium position like this. Okay, now so you see before diffraction, same, after it will decrease like this. So what is this? This one looks very familiar. This one is we learned in the previous chapter. It's called the damping, right? Damping is about over time 它 lose energy. That's why 它 vibrate 会越来越小，越来越小，越来越小。所以 diffraction up to a certain point, the wave, the energy disappears. It's kind of like it becomes very, very, very small until it's like very low, until almost disappear. Okay, because the energy is spread among a very huge area. Okay, so understand the phenomena of the diffractions. And okay, next one. Okay, how do I increase? 比如说啦，我要 increase 这个diffraction 的 angle。OK， 那你看这个最后一个图片呢，如果我要 increase 这个 arrow so that it is larger like this, the arrow I want to make diffraction wider for whatever reason lah. Okay, now I want to make the diffraction wider. I can do one of two things. Okay, now first thing is, okay, I want to erase this. If you want to take a screenshot, you can take a screenshot because I want to erase this. I don't have enough space. Yeah, by the way, I will record all sessions and post it in the group just in case you want to look back anything. Okay. Now, okay, let's say 我们选一个 example the opening we don't take the obstacle, we take the opening. So incoming waves. Okay. Incoming waves. Now, one thing I can increase the spreading. How do I do that? I can increase the wavelength. Okay. Now, for example, let's say this one has a certain wavelength. We call this wavelength D1. Okay, D1. Okay, so the diffraction happens here. Diffraction happens here, 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 here. And then D1, you'll find that it will create a angle of diffraction, and that angle is equal to this angle over here. Okay, so I label this alpha. Theta. Okay, so this is the angle of diffraction. So I can increase it by increasing the wavelength. Okay, in fact, if I draw it again, just a second here. Okay, let's say this one I take a longer wavelength. Okay, longer wavelength. Now what you will find is that a longer wavelength, right, it will create a wider diffraction here. So this one will become wider, and this one wider and wider, like this. Again, before and after the wavelength must be the same. So here 我画到很像很小的那个 space， 其实它这边的 space 跟这边跟 before 都是要一样的，要 have to make sure that, especially when you draw, especially when you draw. Okay, so the wavelength here, the spreading, now you see it is wider. Okay, wider. So here we say that first we say that the diffraction, greater diffraction. So in the test or in the exam, you see this word greater diffraction, it means like this. It means wider spreading, okay? Or greater angle, and also you see wider spread. They all the same meaning, wider spread. Now this is one way, is by increasing the wavelength. Okay, so this one, say this is the D2. Now second one, I can also decrease the opening, this one. Okay, I can use a very tiny slit. 那个 opening 我们叫 slit, S-L-I-T, is another meaning for the opening, the slit. So this is like a single slit, 一个 opening, so single slit. You have double slit also. Later we'll look into that, single slit, double slit. Okay, now you can use a smaller slit. Okay, so you compare this one, it is even tinier, this one. Okay, so the wavelength passes through. You can use the same wavelength as the first one. Let's say 这个 wavelength 是跟第一个一样，然后可是我的 slit 是比较小 ，again 它的 angle of diffraction 也是会 increase， okay， 也是会 increase. So there's only two ways, there's only two ways to increase the diffraction angle. One is to increase the wavelength, another is to decrease the slit, the distance between the distance of the slit or the distance of the opening. OK， 那在 diffraction 里面呢，通常 question 都会叫你画，尤其是在 paper 2啦 ，paper 2，他会叫你画，或者在 paper 1呢，他会那种 ABC 他会画好给你，然后给你选哪一个是正确的。OK， so if they ask you to draw, one thing you have to remember, you need to know how to draw it. OK, so for example, when you draw this one, OK, when you are asked to draw, they give you one obstacle. Sometimes they will give you circle, or like this. Okay, anything like as long as it's an obstacle. Okay, and they ask you to draw. Okay, what is the diffraction? Now, one thing you have to be careful. You don't draw like this. Okay, so these common mistakes are made by students. You don't draw like this because this one is for opening. This is for not for the obstacle one. This is for the opening one. So for the obstacle one, it looks like this. It's a straight and then curve at the end. Straight, curve at the end. Straight, curve at the end. Straight, curve at the end. And it closer like this. Okay. Now again, if they ask you to draw the opening, diffraction through the slit. Okay. Now when you draw, you cannot draw like this. Okay, I make it circle. Okay, so this is wrong. This one, okay, this one depends. Okay, 这里你要注意啊。那首先是你怎样会拿到 circular waves 呢？就是当你的这个 opening 的 distance. Okay, so let's say I draw this one. The distance of the opening. Let's call it D. Okay, let's call it D. And the wavelength. You compare the opening and the wavelength. If the wavelength is the same as the opening, okay, I repeat, this one very important, guys. If the wavelength is same as the opening distance, then you will get a circular waves. Okay, then you get a circular wave. So the circular wave like this. It's completely circular. Okay, it's completely circular, like this. Okay, what happens if the distance is not the same? If the distance is not the same, then you get the one that I drew earlier, like this one. Okay, look at this diagram, bottom left. If the slit distance is not the same as the wavelength, it could be larger or it could be smaller, then you will not get a circular waves. You will get plane waves, but the edges, they curve up. Okay, like this. This is the plane waves, but this is completely circular waves. Okay, so you have to pay attention to this one, because sometimes the question they will test you also. Okay, they purposely draw it in circular waves. Okay, just to trick you. Okay, so you have to know, only if the slit is the same as the wavelength, then you get a circular waves. Okay, if not, you get the plane waves, the plane waves. But all they are still diffractions. They are still diffractions. Okay, now, so for diffraction, what is the use of diffraction? Maybe you ask, what is the use of diffraction? So there are a few. If you look at this one. Okay, you see this, Now here is you have a harbor. Okay, it's a harbor. Now basically, at harbor, you have this very huge concrete wall. This one very huge concrete wall. So what does it do? The concrete wall will block the waves. Because the waves is coming from the ocean, right? It's coming from the ocean. It's very violent. All the waves from the ocean is very violent. Especially you have a certain part of the location. For example, like the Indian Ocean, very violent, all the waves, where the many accidents occur there. Okay, so the waves from the ocean is very violent, so it like approaches the shore. So what is the use of diffraction? Is that we install a concrete wall just to allow the diffraction to happen. You see, this one at the concrete wall. So here is the opening, right? Here is the opening. So it's the slit. It's the slit. So when the water waves passes through this slit, it will be diffracted. So you see this all diffracted. Now what happens after diffraction? What happens to the energy? Before diffraction, energy is very high. The amplitude is very high. After diffraction, the amplitude will decrease, right? So that's how we get the calm water inside the harbor here. That's how we get very calm and very smooth water. If you don't have the concrete wall, what happens? All the waves comes in here, and then they'll cause the boat to shake violently, and then they will damage all the boats. Okay, without the diffraction. Okay, so this is how diffraction helps us in producing a calm water around the harbor, just to protect all the ships and the port and anything. Okay, so this is one of the applications of the diffractions. Again, this is for water 嘛 right? Diffraction 它不只是发生在 water waves 它发生在sound waves, light waves, any kind of waves, even electromagnetic waves. As long as it is a wave, then diffraction will happen. So one example for sound waves, look at the bottom. So this sound waves. Now you see a guy is playing music instruments in a closed room. So here again we have the opening slit. So the sound waves also being diffracted, okay, as it moves through the slit here. Okay, diffracted. Meaning that if you stand somewhere here, just behind the wall, where you cannot see the musician, you cannot see him. If you only stand here, you still can hear. It's because of the diffraction occurs around the edges of the opening. Okay. Now same thing. If there's another person standing here, let's say they are talking. Okay. You stand here. Okay. You cannot see each other. But then the sound waves will also bend around the edges here. It will also bend around the edges. Okay. And that's why you cannot see him, but you can hear him talking. Okay, in every corner in the streets, you see all the corners. Sometimes you hear people talking on the other side. Okay, so this is one simple proof that diffraction occurs in waves. Okay, regardless of the types of waves. transverse wave or longitudinal wave, all they occurs diffractions. Okay, 然后等下我会讲到那个 diffraction of light waves, which is a very typical questions that we'll be asking. Okay, so basically that is about diffractions. Nothing much. You need to know what is the same, what is not the same after the diffraction, and also the principle and how to draw it. Okay, so all of this, if you okay with all three of these, should be no problem for this one. Now next one, I want to talk about the superposition. Okay, now I only left 6 minutes. I will create another link because later I have to erase all the drawings again. So I will create another link and you guys join. I'll continue from there. Okay.